Welcome to the viewers. Now we discuss the action principle and here we derive the action of the path. At first, we encounter the motion of virtual displacement del qy, which is consistent with the conditions of the constraint. And if we see here from the given figure, it is a generalized coordinate qi and it is time, and if we consider here the actual motion, and here we find another path, that is a virtual motion. And now let us imagine the surrounding the surrounding actual path C. If we consider here the path, if we taking here the point, if we consider here P0 to P1, and if we consider here the actual path C, just like this actual path, if we consider actual path C, by a family of neighboring virtual paths C dash, if we note it here, that's a virtual path C dash. The virtual displacement no passage of real time is involved. If we consider the effect of rate of change of del qi, we see ddt of del qi. If we adjust this term, then ddt of qi plus del qi minus ddt of qi. It's very much clear. Ddt of here qi, not qi dot, so it will be ddt of qi plus del qi minus dqi dt, taking it equation number 1. So the RHS of 1 is the difference between the generalized velocity of virtual path and generalized velocity of actual path. We find it here, virtual path and actual path, generalized velocity. And now, in other words, the change of velocity in one step corresponding to the neighboring curve. Thus the change of velocity directly from actual path to the corresponding point on the neighboring virtual card neighboring virtual card. Thus ddt of del qi, that is ddt of del qi is equal to del of dqi dt, that will be del qi dot, and if we take it equation number 2, and the joint action of the actual displacement, joint action of the actual displacement is d, and the virtual displacement is del, is thus commutative, that is d of del equals to del of d, taking it for equation number 3. Now if we take Lagrangian, we have virtual displacement of Lagrangian, that will be I of 1 to up to n del L del Qi plus del L del Qi dot del Qi dot, taking it equation number 4. And therefore if we make a slight adjustment here, I equals to 1 to up to n del L del Qi minus ddt of del L del Qi dot del Qi plus ddt of sum of I equals to 1 to up to n del L del Qi dot del Qi. Now it should be noted here, ddt of del L del Qi dot del Qi, if we take it as product derivative, we find here for ddt of del L del Qi, for the using product derivative rule generally, plus del L del Qi dot ddt of del Qi, and here ddt of del L del Qi dot del Qi plus del L del Qi dot using the commutative property, using here the equation number 3, they are commutative. So del of dQi dt here. So it will be finally given del L del Qi dot virtual displacement del Qi plus, here it will be, sorry, here dq dt, that will be Qi dot. So del L del Qi dot del of Qi dot. Finally we find this type of result. Using this type of result we making the adjustment, taking minus, subtraction, and here adding. So we are finally getting this result. Now making this equation number 5 using Lagrangian equation. Lagrangian equation in classical mechanics, del L del Qi, that will be ddt of del L del Qi dot, we have in 5 using, that will be 0. So finally find del of L equals to ddt of sum of I equals to 1 to up to n del L del Qi dot del Qi. It will be del L del Qi dot equals to del L del Qi, and here we find here del L del Qi dot. Finally find just a few seconds. Finally we find this result and did it. Okay, now taking del L del Qi, that equation number 6, the appearance of total time derivative in RHS of 6 that is here, these equations del L ddt of sum of I equals to 1 to up to n del L del Qi dot del Qi, virtual displacement of del Qi, RHS of 6 imply if we integrate from initial time t0 to final time t1, say if we consideration, it is our consideration initial and final time, that's a latter time, then integral t0 to t1 del L virtual displacement dt, that will be sum of I equals to 1 to up to n since ddt, so that will be integrable. And if we take this integration totally abolished and using the bracket terms of equation number 6, it here just we consider only this term, this will not be there. So del L del Qi dot virtual displacement of Qi T0 to T1, taking it equation number 7. If we write that some S dash of Qi, then it will be integral T0 to T1 Lagrangian of Qi dot and time t dt. If we take equation number 8, we notice del S dash correspond to LHS of 7, that means this, because due to equation number 2, that is this equation, ddt of del Qi, that will be del Qi dot, that is ddt of del Qi is equal to del of dqi dt, that will be del of Qi dot. So we can write del of S dash, that will be integral del of L dt plus integral L of del of dt. But now using the property here, del L dt plus integral using the commutative property d of del t. Del of dt means d of del t. So it will be integral del L del t for a virtual variation. That means del t equals to 0. So if we consider S dash Qi, which is functional, is called actual path. And it is time integral of the Lagrangian between terminal values t0 and t1 along a path. There's a particular path qi of t. So we represent seven as del of s dash that will be sum of I equals to 1 to up to n. If we consider as a pi del qi for integral t0 to t1, taking it equation number 9. And if both the actual and virtual path coincides at t0 and t1, that's initial and final time, then del qi vanishes at t0 and t1. That can say if actual and virtual path coincide then del s dash, that will be sum of I equals to 1 to up to n pi del qi for t0 to t1 will be 0. But here is py is sum of I equals to 1 to up to n del I and pdi, that is sum of I equals to 1 to up to n del l del qi dot, this pi represents, and that will be 0. That is virtual displacement del qi vanishes at t0 and t1. So del virtual displacement del s dash will be 0, taking it equation number 10. We are thus in position of state of principal stationary actions. Now here this SQ dash, and that we derive the action of path SQ, which is also functional, and we discussed already the property of virtual of the functional values, and it will be 0 if initial and final time will be 0. And today we end our discussions. If you like this video, like it, share it, and don't forget to subscribe the channel. Thanks for watching.